This is A-level mathematics, chapter 9, Trapezium Rule. When we're doing the Trapezium Rule, we're approximating the area under a curve in between the 2 points. So what we're doing here, so here is one example. So right here we have the equation f of x, so we're finding the area under the equation f of x in between a and b. So this would actually give me, so normal integration would give me the area under that continuously, all of that shaded. Okay, this would give me the exact answer on this. Now, when we're doing this one right here, using trapezium rule, is I'm going to turn this into a trapezoid. So if I look at this very carefully, I'm going to turn it to the side. So I have a trapezoid here. So I have a slant from here to here. I have, this would be like, if you're doing a normal trapezoid, this would be like the B1, this is B2, and your height would be the separation in between A and B. So my normal formula for trapezoid is, it's going to be 1/2 h, and that's what we have here. H would be the height, it's going to be the difference in between here and here. That's that. And B1 plus B2. So B1 is actually going to be the height of this. And so what that means is I'm going to find from the x axis up to my curve. So from here all the way up to here, all I do is plug in my value here, and it's going to give me the y value, which is that height. And then a height, which is going to be here. It's going to be my equation. So I'm going to plug in the b, whatever my b is here. So, and that's going to give me my height, my y value from here. So, it's going to come out to be this my height, this is my B1, and this one B2. So this is this height and this height here. So all I have to do is just plug in for those. So this is actually referred to as the simplest form. So the simplest form for this. So this is only going to make one trapezoid out of this. We're going to do this later on when we are looking at this, and it's actually going to give me a closer to the actual answer. So if you look, if we're approximating, look at the piece that's shaded right here. So if you notice, there's a gap right here from what this is to what this is. So there's a piece that is actually not shaded, so I am not including that in my estimation of the area under this curve. So that means that when I have it like this, I have that gap there. This is going to be an underestimation. So I'm actually underestimating when the actual curve is here. Where this one right here is an exact value, and this one right here, since I do have a gap there, this is going to be an underestimation. I'm going to give you an example later on of an overestimation. So if I'm going to do A, so let's go ahead and take a look at A, and we're going to use the simplest form, which we have here. So this is going to be, so it's going to be approximately 1/2. So B minus A, so it's going to be 1 minus 0. And the next one's going to be f of A. So it's going to be my equation, so it's 1 over 1 plus A. Right here, my A value is 0. 0 squared plus 1 over f of b. So right here, here's f of b. So my b value here is going to be 1. So 1 plus 1 squared. So if I go ahead and do the math, I get 1/2, that's there, times 1 times. So right here, this is going to give me 1 over 1, which is 1 plus this right here. If I'm looking at this, so 1 squared is 1, plus 1 is 2. So that's 1 over 2. So I can go ahead and just throw it in my handy dandy calculator here, because most of these I'm going to end up have to do in the calculator, because I'm going to come up with some weird funky answers, some long weird decimals. So the easiest thing is actually make sure you're able to put in the calculator. So 1 divided by 2, parentheses, 1, close, open. Right here is going to be 1 plus 1 divided by 2, 1/2. Right there. So 1 plus 1/2. Hit enter, and my answer is going to be approximately, because whenever I do trapezium rule, it's always an approximation. It's going to be 0.75 as my answer. Alright, let's take a look at this second example now. So second example, we have approximately 1/2. Okay, so I'm going to do my b minus a again. So it's going to be 1 minus 0. This next one, so for this one, it's going to be the square root of 1 plus 0 to the third plus square root of 1 plus 1 to the third. So let's see what I get. That's going to be 1/2. So 1/2, 1, and this one right here is going to give me square root of 1, which is 1, plus this right here is going to be 1 to the third power is 1, plus 1 is 2, so radical 2. Close. So in the calculator here, 1 divided by 2, parentheses 1, close, open, 1 plus radical 2. Where's that one? Okay, it's here on this one. Radical 2, close, close there. So on my calculator right here, you got to make sure you, whatever you open, you also close. So right here, I'm going to come up with about, this is going to be about 1.21. That 7 is going to make that one round up. There we go. And that is the simplest form trapezium rule. Alright, now, this is a Chapter 9, Section 3. This is another example of trapezium rule, but this is not the simple rule. This is the general form. So general form actually is broken up in a bunch of little different parts. Now, if you take a look at this, now, I actually have same curve, f of x here, f of x, so here's my curve, and then I broke it up into a bunch of little trapezoids. So if I break it up from here to here, that, if you notice, from here to here is closer to the actual line than what I would actually have if I were to go directly from, let's see if I could show this one here. So if I go from here to here, now if we're looking at the difference in between this, if I were to use the general form, simplest form of the trapezium rule, I would actually be only taking the area of from here to here. So that means this right here under the curve would be a gap. All this right here would not be included in my estimation. So by breaking up into smaller pieces, I'm getting closer to the actual answer. So without doing the actual integration, because some of these ones we cannot do the integration for this with the knowledge that we know so far. So there's a lot of weird rules that we're going to have to learn later on to be able to do it. But at this point right now, we could actually solve for these integrals with just doing approximation. So what this means is, so let me zoom in a little bit more so we can take a look at this. All right. So here is, if I were to use the simple form, I would miss out on all that, above the line, below the curve, but above the line. Now, right here, this actually says f of a, so here's my first one. So this is y sub 0, y sub 1, y sub 2, and this is y sub n minus 1, y sub n, and y sub n is my last one, which is f of b. So I would start off with this right here, my y0 and yn, so y of 0 would be f of a. So that's going to be my first value that I have right here. Y of n is actually my last value. It's from here to here. So it's my first one and my last one. Now, this is actually broken up into ornates. Okay, this is going to be how many ornates I have. Now if we're taking a look at this, it has, look very carefully, this one right here, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 different things I'm taking the area of. Now if I take a look, since I had that many right there, I have, okay, let's go with the formula, back it up a little bit. There we go. Alright, so for this one right here, we have the formula. It is still trapezoid again, but the problem is I have to have my first, so this is actually going to be how many times I'm going to break it up. So I would have all these, so since I had 1, 2, 3, 4, 5, 6, 7, 8, 8 separate areas that I'm adding together here, where I had this, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 ornates through here and 8 areas. So that's why it takes a look like it's going to be like just n minus 1. So because I'm starting at 0 from here. So let's take a look. Right here it says trapezium rule with n intervals with n plus 1 ornates. Ornates means the y coordinate. Close that. Where h in my formula, h is the height, it's going to be b minus a, so it's actually going to be my, right here, so it's going to be my last one minus my first one, divided by how many. So the number that I would have for how many intervals I have. So it would break it up into that many pieces, and it would be, ornates would be plus 1 to that, and that's what that means. Ornates is just the value going straight up, so it's actually how many of these lines that I'm going to have here that separate and give me the 1, 2, 3, 4, 5, 6, 7, 8, the 8 areas. So again, my formula is going to be 1/2 h, which I figured out, it's right here, quantity, so y sub naught minus yn, so that's going to be my first one plus my last one, so it's going to be from there to there, plus 2 times the quantity of, so I have to do the y1, so it's going to be the y1, so it's this height plus this height plus this height, and dot 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 all the way up until not the last one, because I already did the last one over here, one less than the last one. So that's what that means. So it's actually going to be, so I have my first and last here, then plus 2 times the quantity of what I have inside here. So all those added together. Now, hopefully this is not too confusing, but if we actually put some numbers in there and try and do it, it will make a whole lot more sense. Now, let's take a look at what we have here. So Chapter 9.3.1 use trapezium rule with 5 intervals. So if it's 5 intervals, it's going to be 6 ornates to estimate the from 0 to 1, 1 over x squared dx, correct to 3 decimal places. So I need to take a look. So I need to find out a couple things. So first, it's going to be about 1/2. So I'm using my formula. Quantity here. So from here, so y sub 0 plus y to n. Before I do that, h. Gotta throw in that h. So the h is going to be b, so it's going to be the second value, so it's 1 minus 0 over n. So n is going to be how many intervals, so the number of intervals is going to be 5. So I'm going to bracket this, just because I feel like it. So that's going to be my h value, times so times all this here, and so now it's going to be y0. So start off with the first one, which is going to be 1 over my function 1 plus x squared. So it's going to be right here, 0, is going to be at 0 squared plus, and here plus y sub n, so it's going to be 1 over 1 plus 1 squared, close that, plus 2 times 1 over 1 plus, now this next one here, this is actually going to be, if I back it up a little bit right here. Now, since I started right here, this is my first one, so my next one's going to be whatever my interval is, so I'm going to add that to here. So I'm going to take it and I'm going to add this piece, my height divided by 5, okay, and I'm going to add that to my next one, and that's going to give me my next value there. So this next one here should be right here. It's going to be 0.1. So this is 0.1. Oh wait, 0.2. I'm sorry, 0.2 squared. Because make sure clear. I get 1 divided by 5. That gives me 0.2. So my interval, so each one is going to go up, and it's going to be going up 0.2. So I started at 0, and so next one's going to be plus 1 over 1 plus 0.4 squared plus 1 over 1 plus 0.6 squared plus 1 over 1 plus 0.8 squared. And if I were to do that one more time, I would get to my 1, and so that was my last term. So this is my first one, which I start off with at A. So that's where I start off with here, at my A value. And then this is my last value, and this is my B. So I started from 0 and went to 1, and I went in increments of, when I did this, it was 0.2. So I continually go up, so each one's going to go 0.2 more for this. So each one 0.2. So if I keep going 0.2, 0.2, right here. 0.2, 0.2, 0.2, 0.2, all the way up until I get to the end. This last one would be B. So I'm doing all the increments in between there and there. So let's see if I can fit that. Yes, there we go. So inside there. Now, having the 2-line input on your calculator is going to be very, very, very beneficial, because it's going to help you out here a lot. Because you could actually track and keep track of everything. Otherwise, you're going to have to take it down, write it out, and then plug it back in. So less work. So I have 1 divided by 2, open, so we don't have brackets on the calculator, but parentheses. So inside there is going to be, let's see, the 1 minus 0 is going to be 1 divided by 5. 1 divided by 5, close. So I got the H, and that's what that is right there. Okay, right here, this is going to be open again. This one right here is going to be, now I can put this all in the calculator as long as I know how to put it in correctly. So first thing I need to do is understand that when I do put this in the calculator, since I have more than one thing in the denominator, I would have to add extra parentheses there. This is a very, very helpful thing to learn, because when we get into problems that are really complicated, you want to just put it all in the calculator all at once. Because later on you might actually have something weird here, and you might have something weird here. You'll have to parentheses top and bottom, but right here on this one, I'm going to show you how to do it all in the calculator, all in one step. So now we're right here. So it's going to be 1 divided by, open again. So I'm opening that one. 1 plus 0 squared, close, so that closed that. Now, since I have that, now I can go to plus 1 divided by, 1 divided by, open, 1 plus 1 squared, close, right there. Now, close that again. because I closed it there. Plus 2. Next thing is open 1 divided by 1 plus, I'm sorry, there's a parentheses there. Parentheses, let's skip that one. 1 plus 0.2 squared, close, that took care of that, plus 1 divided by open. I'm going to have 1 plus 0.4 squared, closed, took care of that, plus 1 divided by open, 1 plus 0.6 squared, close, plus 1 divided by open, 1 plus 0.8 squared, close. So now I close that one. Now I have to close this one right here, which I opened right here because it's 2 times all of this. Close that there. And then because I started here with the open over here, I go all the way to this one over here. So I need to close it one more time to actually say that all this right here is being multiplied by what I have in front. So since I have 1/2 times 0.2 times all this, let's see. Alright, enter. And I come up with about, so this is going to be about 0.78. Okay, 0.7837, so that's going to be, if I'm doing to the third, correct the 3 decimal places there. So it's going to be, I look at the 7 makes that into a 4, so 784. And we did the same one on the previous page where using the simple approximation I came up with 0.75. So if you notice, this one right here is going to be closer to the actual value of my integration, where the other one is an approximation, which if we're comparing the two, this is closer. So right now, just by using the different intervals, this one's going to be, let me see, 0.034 difference than what I had on my other one. So the more intervals that we use, the closer my answer is going to be to what the actual answer is. So if you ever get into a situation where you need to find an interval and you cannot seem to do it, you can use the trapezium rule. If you use enough intervals, your answer will be so close to the actual answer that there wouldn't be a difference in between. Now, let's take a look at, let me back this up a little bit, right here. So now, if I'm going to take a look at this, let's see right here. Now, what I'm going to do is, I'm going to go and I'm going to do each piece individually, because we have some people that don't have the 2-line input calculator. So I'm going to show you how to do it piece by piece. So right here we have 1/2 times, this right here is 1 divided by 5, close, okay, open. Now this one right here is going to give me, let me see, this, just this by itself is going to be 1. This right here is going to be plus 1/2, close, so that's going to be my first part, plus 2 times. Now, to do this one right here, it's going to be, let's see, that's going to be 1 over, clear, 1 plus 0.2 squared, and that's going to be 1.04 plus 1 over, the next one's going to be 1 plus 0.4 squared, 1.16 plus 1, so it's 1 plus, this one's going to be 2, 4, 6.6 squared, 0.36 plus right here, so 1 plus 0.8 squared, so I get 1 over 1.64, so that closes all that, and that would be times there, and then that would close the end, because a lot of people are going to have trouble with the parentheses part on all of these. So I'm showing both ways. Okay. So you can add these all up in your calculator, add those up times 2, and then you could actually do this piece by piece. So you have this, bring this down, so this would be 3/2 plus whatever you get for over here, and then do it piece by piece. So if you're going to do it like this, please make sure that you're actually carrying down all your work for this, because otherwise you're going to end up losing a lot of your information. And if you get it wrong when you're trying to input it in the calculator all together at once, go back and try and work it out like this. Okay, because you know what, it doesn't hurt to show more work, but you know, if it's going to help you get the correct answer every time, then you know, show as much work as you can. Alright, so let's take a look at, we're going to do the difference between estimations. Now, this right here is a graph. So this is my f of x. So the curve is f of x, where my line right here, this is actually going to be from A to B. So if I was going to use the trapezium rule in between from here to here, this would be an overestimation, because if you notice, when I make a trapezoid out of this, it's actually going to be above the line. So it's actually going to be more than what it is under the curve. So the under the curve is only this piece right here under there, but this would actually be an overestimation. Now if you look right here, this is another weird one that you might see. Now if I was to do here, going from here to here, I would go from the beginning here to the beginning over here, I would come up way under. So you might actually see this. This is again an underestimation. So if you notice, it's underlined. There is a gap right here in between here and here. So it's less than what the curve is. So this is going to be under here, and there right here is going to be another under. Now you're going to see some of them where it's going to be a weird wave, where you have, for one segment of your line, you're going to have an overestimation, and another segment of a line, you're going to have an underestimation. So on some like that, like if we're doing the area of a sine wave or a cosine wave, you might end up actually getting the exact answer, because you're going to overestimate and underestimate the same amount. So you would actually end up getting the same answer, the actual answer on that. But that's only works out when we get certain waves. Now, for this we have the practice. The practice is going to be 1 through 10 all, and the homework is 1, 3, 4, 5, 9, and 10. Now, there's a couple of them that say draw. Please go through and actually draw your pictures for these. It's going to be very helpful. It's beneficial if you look at it back later to understand the difference between the overestimation and underestimation to be able to get the correct answer.